I think we have some guests from Germany and from Valdaura. And yeah, first thing, any general questions regarding the class? Something you didn't understand?
I have one question about materials. Just at the end, I think you were talking about MDF, and I noticed with the comment use MDF. So what's the analysis about MDF?
Okay, the question is like how good or bad is MDF for cutting with a laser? And yeah, actually we cut a lot of MDF. It makes a lot of black smoke that stays inside the laser. It's not my favorite material, but it cuts very nicely, and if you clean your laser regularly, it shouldn't be a problem. Okay, so first thing I wanted to show you was just a bunch of pictures. So if you look at the classes from last year, so this is just a random collection of pictures I found going through the pictures on the MIT website. So you can do anything from a piece of furniture. And actually there's people doing crazy stuff with cardboard. Like first, what do you think when you hear only allowed material is cardboard, you think like, what? What should I do with cardboard? It's very soft and nothing very strong. But actually you can make almost anything out of cardboard. There's people making beds out of cardboard, people that put their television onto a cardboard furniture. You can make stools out of cardboard. You can make little houses out of cardboard. So don't feel limited. This one is a wine bottle holder, which is quite nice. It's all the same piece that snaps together for putting wine bottles. This one is an interesting one. This one is interesting because it combines the cardboard with another element, which is a straw. So feel free, if you have some material that you would like to use together with the cardboard, no problem. Straws are cheap and quite stable if you use them in the right way. But the basic requirement that we all have to fulfill is to make something that fits together and stays together. This is what you want to learn. If you just make a design and you send it to cut, it won't stay together. It will just fall apart again. So we have to learn what the curve is. So if I refer to curve, this is the thickness of the line that the laser is cutting, usually about 0.25 millimeters. And curve compensation is what we want to learn this week. Yeah. So if I say 0.25, this is different on every laser. It depends on how clean the laser is, how new the tube is. Like the laser tubes degrade over time, so they get weaker when they get older. It depends on how well your material is focused. There's a autofocus. Sometimes you have to focus manually. Depending on how well you do this, the cut is going to be thinner or thicker. It depends on the thickness of your material, because the laser cut is not straight. It's like it's V-shaped, and you can decide if you want the V on top or on the bottom or somewhere in the middle of your material. But in any case, you will get something that looks like an X. So it's only focused right at the crossing of the X. All the rest is slightly tapered. So if you have very thick material, your cutting width will be wider on some point than on another. Then we have acrylic. Acrylic also cuts very nicely, but I don't like it as a material because it's very brittle, it breaks very easily. If you have sharp corners, after a while pieces just break by themselves, even without touching them. This is a detail of the one with the straws. So you can see that in addition to just snapping together, he also has a little hole where another pin snaps inside. So you lock it and you have to take out the pin in order to disassemble it, which is a very nice idea. This way you can make very robust structures out of cardboard. Another detail of the same one with the straws. This looks like a clothes hanger. Oh yeah, it's already has a jacket. Cardboard shoes. I think they're great. Like, yeah. And if you, yeah, this looks kind of like a joke, but if you look at the SolidWorks drawing, you realize that there's quite some work going into that. Then, of course, you can use different materials. You can color your cardboard. We have lots of paint. If you want to get more creative, go ahead. This one is probably made on the vinyl cutter, and it's another option for showing you that you not only can you make snap fits that lock together, but you can also make them adjustable. So you can make one snap fit that snaps in different positions. So you can make like adjustable hats or shoes or whatever you come up with. And this one goes more in the direction of origami. If you want, I have a few origami programs that I can recommend you. Maybe I'll put this on the list.
Yes.
Yeah, in the next moment. You can do useful stuff. This looks like a something for putting your clothes or for carrying firewood. This one looks very nice. You can hardly see the joints, so you must have some clever way of hiding them inside. And it's probably quite stable because the cardboard is very easy to bend like this, but very hard to bend in the horizontal direction. So if you make some ribs, you can make your objects much stiffer. This is just a very simple test, but you can already see that there's some little hooks here that fit into here. This is probably very small. But of course, the little hooks, they wear out over time. So probably you can come up with something that is a bit more flexible. So you don't just like smash your hooks, but you keep them flexible. This one is a nice one. Maybe you've seen this one before. It's a lamp you can buy in IKEA. It has a name. It's just one shape. It's one shape that looks a bit like an S, but you can snap it together to make lamps in any size. If you make it from paper like this one, they go nice and translucent. So if you put a lamp inside, you can make a beautiful lamp. All right, this one is kind of a classic. This one is hanging in my room and very small. I like it. So this is very easily achievable with 1-3D. And I'm not sure, like Neil decided just before class that it has to be a parametric design. I'm not sure if 1-3D counts as parametric, but it kind of is, because you can go and change the settings for your curve in the preferences. Yeah, it's quite nice. The 1-3D make is getting better. Now you can also do unwrapping of 3D models. You have 3 or 4 different ways of stacking cardboard for making designs. It labels everything for you. You will have to go through the trouble of generating a PDF, opening it in Inkscape, post-processing it, giving the correct colors to the correct lines so that one part gets engraved and the other one gets cut. But that's very easy. I really like a plugin for Blender that is called Paper Model. So I will also go through installing and using this one. And there's definitions in Grasshopper for doing these structures that fit together. Like you see some pictures up there as well. How do we call those? A waffle structure. So you can do this in very small or in very big. I think in Sevilla they have a waffle structure that is maybe 50 meters high. I can show you after. So everybody gets 1 square meter of 4mm cardboard, but if we run out of cardboard, we can buy more. So you don't feel limited by it. Right? Yeah, and we have vinyl and we have cardboard. Then this is a little detail of a press fit in MDF. Something a bit more three-dimensional. This one is nice as well. This is a funny hat or a flying saucer. Oh, this one is a windmill. It's a vertical axis windmill. So yeah, I'm sure you can come up with some useful stuff. Like as much as I don't care so much about the waste of the cardboard, I always do like to make useful things. So if you can build something that you can actually use. For my Fab Academy, I built a lamp that is very useful because I really needed a lamp, so it was a perfect solution. So I guess since most of you just moved to a new flat in Barcelona, maybe some lamps, or maybe something for putting your dirty clothes, or a little sculpture on the wall. Well, we haven't seen any houses in this assignment yet, but surprise me. And this one is the grasshopper definition of a model that transforms a DNA structure into a cardboard press-fit structure. I guess you can tell that he spent what he did in this week. Looks like a little, like a bush, almost like a forest. Paper planes. You can also make great toys with it. This is the DNA structure, so this is what Grasshopper is actually generating. You can also bend cardboard to a certain degree, so you can make structures like this one, which turn quite strong. As soon as you have bending in one direction, you get a lot of stiffness. I like this one. It's a little racing track for playing for little cars. So I think this one just had a little son or a little daughter, and so he decided, or maybe it's even for marbles or something. But there's a game to it, so you have to push the marbles through the holes and go around the obstacles. Maybe you can go with 2 teams and fight against each other. And you can make it a real construction kit. If you Google for Neil Gershenfeld on Wikipedia, you can tell that he's famous for some construction kit, the maker kit or something. And if somebody manages to find out what this exactly is and where to get the files for it, I would love to build it. Okay, this one I don't know what it is. It looks kind of interesting though. It's also making use of the bending. This is the one with the straws in like another dimension. And this one is, you can tell that you can make different things with it. So it's a little dog, or, well, I don't know what the other one is. Oh, yeah, great. Shot glass holder. So if you can come up with something that might be useful for the lab, actually I'm working on well, not the shot glass holder, but anything for holding screws, for holding components, maybe for securing your board while you're soldering it, or I came up with a parametric design for making cardboard boxes that I'll happily distribute. I made it in SolidWorks. Works really nice. Makes a cardboard box that folds together without any glue, so you get a nice box with a lid. It stays closed. But I would love to have it in OpenSCAD, so I could put it online and use it in Thingiverse. If somebody's up to that, I have all the formulas. It's just about doing it. And yeah, I think this is some vinyl cutter things. The vinyl cutter is, you don't have to do it this week, you just have to do it at some point at FabAcademy. And right now our program is very busy, so we have tomorrow we're doing the general introduction to the lasers. So we're going to try the 3 lasers that we have. And maybe if you find some time after, or if somebody, but I guess as soon as you know how the lasers work, you want to cut some stuff, and you will be cutting things. Okay, and I think this is a view of somebody's teeth. I don't know, maybe there was a dentist in FabAcademy. This one I think is the windmill again. And actually, the windmill is adjustable. So you can turn one piece against the other and adjust how wide it opens. So you can actually do mechanics and all kinds of movable things in cardboard. There's a few programs that I could recommend you for doing kinematic analysis. Yeah, if you're interested, tell me and I'll give you some tips. Oh yeah, this is the DNA model. So this is actually simulating the different bases of the DNA. So it's really, probably it's the DNA of the producer himself. Oh yeah, and the bike helmet. I really like this one. Maybe you can do, yeah. Last year, Taiji, he made some shoes, and he was actually wearing them quite a lot. Yeah. So, yeah, be creative. Oh, Lego pieces. Of course, you can just copy anything that you come up with that is already modular and make it out of cardboard. Okay, this wheel, I wouldn't trust this one too much. Another technique for joining pieces. Yeah, so as you can tell, there's more than one thing you can do with cardboard.